For example number 4, we're going to use synthetic division to help us find the quotient and remainder. When we take 3x cubed minus 4x squared plus 5 and divide that by x minus 3 halves. The first thing I want to do is I want to make sure that our numerator, that our dividend is in proper degree descending order, which it is. We have our third degree term, we have our second degree term, and we have our 0th degree term. Notice we're missing our first degree term. In log division, it doesn't matter. In synthetic division, we have to have it there, which means I'm going to rewrite this using 3x cubed minus 4x squared plus 0x, because I don't have that first degree term, so I'm going to write a 0 there to represent that, plus 5. And then when we look in our denominator, we have a first degree polynomial, right, because its x is the same thing as x to the first, which means it's a good candidate for synthetic division. All right, so let's begin the synthetic division process now that we have everything in proper standard form. In our little L-shaped thing, we're going to put the 0 of the denominator, and the 0 of the denominator is 3 halves, because 3 halves minus 3 halves is the same thing as saying 0. In our numerator, we're going to have our row matrix, and that's going to correspond to each one of the coefficients of the degrees in our dividend. So I'm going to rewrite that in our dividend as, rewrite our row matrix as 3, -4, 0, and 5. So synthetic division works as follows. We're going to drop our first term, and our first term is 3, so I'm going to drop my 3. Once a term drops below this horizontal line over here, then we're going to multiply it by the 0, by the number in the chair. So 3 times 3 halves is the same thing as saying 9 halves. So over here, we're going to put 9 halves. Okay, so in this case now, we're going to add down. Once we put this number over here in this position underneath that next coefficient, then we add. So -4 plus 9 halves, well, that's the same thing as saying -8 over 2 plus 9 over 2. That's going to give us 1/2. So we're going to take 1/2 and we're going to drop it down over here. Again, once the number crosses that line over there, then we're going to multiply it by the 0 or the number in the chair. So we're going to multiply 1/2 times 3 halves, and we get 3/4. Put it underneath that next coefficient, and then again, we're going to add 0 plus 3/4 is 3/4. Once it crosses the horizontal line, multiply it by the number in the chair. So we're going to multiply 3 halves times 3/4, and we get 9/8. Put 9/8 over here, and then we're going to add again. So 5 plus 9/8. 5 plus 9/8. Well, that's the same thing as saying 40 over 8 plus 9 over 8, and that gives us 49 over 8. So we get over here 49 over 8. Whatever that last term is, put a box around it because that's going to represent our remainder. All right, so what does this mean, this 3, 1/2, 3/4, and 49 over 8? Well, we took a third degree polynomial and we divided it by a first degree polynomial. And remember, the base is the same when we're dividing, we subtract exponents, which means we're left with a second degree polynomial. These are the coefficients of the second degree polynomial in degree descending order. So this first term is equivalent to saying 3x squared. In degree descending order, after x squared would be x to the first, is plus 1/2 x to the first. In degree descending orders is our constant term, or x to the 0, so plus 3/4. And this 49 over 8, that last term is going to be our remainder, and we're going to write our remainder plus 49 over 8 divided by our original divisor, which was x minus 3 halves. So you can leave your answer like this. This isn't really standard, so I'm going to get rid of that 1. And it's not pretty, but we can write our answer in this form.